Hello, 3U. We're on our first day of rational variable expressions, and I will forever be lazy and call them RVEs. We're basically doing a unit that is much more focused on algebra, so you need those skills to do this. Polynomials, first of all, we should give you a definition for what the term means. A polynomial means literally a collection of terms or many names. Collection of terms is mathy and many names would be literal. So we have already looked at polynomials before and even heard such things as, for example, a monomial would be a one-termed thing. 3x would be a monomial. Ax squared would be a monomial. There is one thing. Binomial, which we looked at in grade 10, is two things, something like x plus 2, a minus 7. Those would be good examples of binomials. Trinomial is what we started last year and caused us a little frustration. Three things, three different things, some x squareds, some x's, and some numbers would make an excellent trinomial. So today our focus will be on all the operations that we do with different polynomials, all sorts of different sizes. So the first one, for example, we've been asked to simplify two binomials. So if possible, we do whatever is in the brackets first, and we would collect like terms. So simplifying basically translates to do the operations that you can and then collect like terms. 3x plus 4 plus 5x minus 2. The brackets only significance is to delineate the binomials. So you can see there are two different binomials, but there are no operations that we can do to tidy up the inside of the brackets. We just add like terms. So if you wish, you can write it without the brackets because they don't serve a purpose. And we can put it together. My x is in one pile and my numbers in the other. The second one is also the addition of two binomials. Inside the brackets, there's nothing I can do to tidy it up, so I'm going to collect like terms. I have some y's here and some y's there. Be careful of your positives and your negatives, but I have negative 1y added together with negative 4y. I have negative 5y. I also have numbers. I have positive 2 adding to invisible positive 3 plus 5. For C, I have two trinomials which have the identical names in the terms, a cubes, a squareds, and a's. To collect like terms, I need to put like with like, a cubes, a squareds, and a's in different piles. Watching for my signs, I'm going to look at my a cubes first. We generally do order, highest degree to lowest degree. So my a cubes would be first. I have 6 of them. Added to negative 4 of them, I have 2. My a squareds, I have negative 3 added to 8 of them. I have 5 of them. And lastly, my a's. I have 4 of them. Added to negative 2 of them, I have 2 of them. The last one, they're also trinomials, a little bit different. X squareds, xy's, and y squareds. Keep my piles separate because they are different. And you can't add apples and oranges. X squareds first, I have 3 of them added to 2 of them. I have 5 of them. My xy's are second. I have 5 of those. Added to negative 3 of them, I have 2 of the same name. Lastly, I have 6y squareds and negative 4y squareds. I have 2 y squareds. So when doing any operations on polynomials, we would simplify and collect like terms always. Don't leave it all a mess. Recall as well, I know you know this, but we're going to go over it. We're going to do the distributive law. When we squish something up to something else in mathematics, multiplication is implied. So if I have a squished, I told you we were lazy. If I have a squished up to x plus y plus z, it means a times, and it's going to be a times everything in that bracket. What has really worked for me in the past is to draw my arrows to make sure that I multiply everything behind the a by a. In other words, a affects everything directly behind it, which is a bracket. So everything. Ax plus ay plus az. A plus b times x plus y are two binomials being multiplied. What we are going to do to multiply those is to make sure that a gets multiplied by both the x and the y, and that b gets multiplied by both the x and the y. That's the distributive law gone a little crazy, and we have a memory device to help us with that. FOIL. First would be the a and the x, first in both brackets. Outside would be the two terms on the outside as far away as possible from each other. That would be the a and the y. Inside would be the two terms that are closest together. Inside that equation would be there to there. That would be inside. Oops. And L for last. L would be the last in both of the brackets, the b and the y. That is a really quick run of grade 10 algebra, basically. Let's FOIL it. First, outside, inside, last. My firsts would be a times x, which is just ax, plus outside is a times y, ay, plus inside b times x, bx, plus last, dy. And I very carefully made sure I've multiplied a by both and b by both. On to our next slide. Three times 4t minus 8 plus 6 times 2t minus 1. So our job is to do any operations and then simplify by collecting like terms. I see the distributive law, 3 times 4t minus 8, and 6 times 2t minus 1. I honestly draw arrows every time. Line number 1 would be multiplying 3 times that bracket, 12t minus 24, and then 6 times 2t, adding 12t, adding 6 times minus 1. So you can write it as add minus 6, or you can write subtract 6. Next line is to collect like terms. I have t's and I have numbers. I have 12t and another 12t, 24t. For numbers, I have negative 24, add negative 6, negative 30. Done. The next one is missing a bracket. Oops, sorry. Negative 10b, negative 4, take away 8b plus 7a. So I have b's and numbers and a's. We're going to collect like terms. There are no numbers out the front, so I don't have any distributive law to do, except this negative can be a problem. Subtract means subtract each part of the bracket that's following. I would write it out. Negative 10b, take away 4, and then I'm going to subtract 8b, and also subtract 7a. Now I can collect like terms and simplify. For b's, I have negative 10 of them, take away 8 of them, negative 18b. Take away 4, subtract 7a. I can't put anything else together, they're different. B's, numbers, and a's. Next. I have distributive law, 7 times 3w minus 4, take away 5 times 5w minus 3. Draw our arrows. And be careful with the negative sign. 7 times 3w is 21w minus 28. Then I am going to subtract 5 times 5w, 25w. And then I am going to subtract 5 times negative 3, negative 15. Some of you noticed that you had a negative times a negative, and right away wrote that as positive 15. It doesn't matter, but you need to be very careful with your positive and negative signs. I'm going to put my w's and my numbers into their piles, collect like terms. I have 21 w's. Take away 25 w's, I have negative 4 w's. For my numbers, I have negative 28. Take away negative 15 is the same as add positive 15. I end up with negative 13. And another bracket. I'm having trouble, I guess. All right. I have two trinomials being subtracted. I have a trinomial with a cubes, a squares, and a's. And I have a subtract, so I need to be careful. For my a cubes, I have 8. Take away negative 4 of them is the same as 8. Add 4 of them. I have 12 a cubes. Negative 3a squared, take away 7a squared is more negative, negative 10a squared. And my a's, I have 6 of them. Take away negative 3 of them is the same as 6. Add positive 3 of them. There is nothing further that I can do to simplify that. A cubes, a squareds, and a's are all different. Your answer is a trinomial. Number 5, 7d times d squared minus 2d plus 4. 7d is squished up. It means it will multiply itself by everything that follows in the bracket. 7d times d squared. Our rules for multiplying powers are multiply your numbers. 7 times invisible 1. D to the 1 times D to the 2 is D to the 3. When multiplying powers, we add the exponents. We can also make that look like a D. All right. 7D times minus 2D. We multiply the numbers. Then we multiply the variables. D to the 1 times D to the invisible 1 is D squared. Add exponents when multiplying powers. Wouldn't hurt to write it down. Lastly, 7d times 4 is 28d. We are done. Number 6 is 5m cubed times 7mn times 5m cubed, times negative 2. First one, 5m cubed times 7mn. I do my numbers first, 35. Now I'm going to do my m's. M to the 3 times m to the invisible 1 is m to the 4. There isn't an n in the first term, but there is in the inside term. It's just n to the 1. Take away. 5m cubed times 2 is 10m cubed. Done. Those two terms are different. Your answer is a binomial. Continuing on, number 7 is a FOIL. It's distributive law, but it's between two binomials. FOIL helps us remember to get all 4 multiplications. First one I do is t times t, t squared. Outside would be t times minus 2, minus 2t. Inside would be 1 times t. And last would be the 1 times the minus 2. We are always required to simplify and write it in prettiest form, simplified form. We have t squareds. We have negative 2t plus 1t would be negative 1t. You may or may not wish to write the 1. Take away 2. Done. Another FOIL problem. Just a good check sheet. First, 2a times a, 2a squared. Remembering when I multiply a times a, we're adding the exponents. Outside, 2a times 6, 12a. Inside, negative 3 times a. And last, negative 3 times 6 is negative 18. To collect like terms and simplify, I have a squareds, a's, and numbers. It's only the middle two that I need to put together. 2a squareds plus 12a subtract 3a would be 9a subtract 18. The next one looks different, but it's still a FOIL problem. First would be 3 times 2, outside 3x, inside minus 4x, and last minus 2x squared, because an x to the 1 times an x to the 1 is x squared. It's backwards. We normally would write highest degree to lowest degree, so I'm going to do my x squareds first. My x's in the middle, I have 3 of them and negative 4 of them. I have negative 1x, and my numbers last. M plus 3 squared. Please put a big star. This one gives students headaches. M plus 3 squared means m plus 3 times m plus 3. That is a FOIL problem. First, outside, inside, last. M times m is m squared. Outside, 3m. Inside, 3m. And last, 9. Collecting like terms, m squared plus 6m plus 9. The next one, the challenge with that one is that you have 3 things being multiplied together. And I can only multiply 2 things at a time. So it doesn't matter. Order of operations says I can do this first or this first. Doesn't matter. I'm going to start by multiplying 3 times 2 plus 6x. So I will get the bracket 6 plus 18x and rewrite the next bracket as it is. Now I have a FOIL problem. First would be 6 times 3. Outside would be negative 6x. Inside is 54x and negative 18x squared. Last example. We have distributive law, add 8, then another distributive law, collect like terms, and simplify. 2 times t minus 6 is 2t minus 12. The add 8 is just by itself. And then distributive law again. 4 times t is 4t, plus 4 times 7 is 28. Then I collect like terms. I have t's, 6t altogether. My numbers, when I put them together, would be 24. Last 2 examples. 13 is also multiplying 3 things. You can only do 2 at a time. It is your choice which 2 you would multiply together first. I'm going to go for the first 2. b minus 7 times b plus 8. And in a while, I'll multiply that by 3b minus 4. FOIL would give me, for the first 2, b squared plus 8b minus 7b minus 56, bracket, rewrite 3b minus 4. Before I do the next part, I'm going to tidy up that first large bracket. Make it as simple as possible. B squared, I've got 8b, and negative 7b, I have ab, minus 56 times 3b minus 4. We've not seen anything that looks exactly like that, but it is still distributive law. It's like FOIL gone one step further. I need to make sure I multiply everything in the second bracket by, first of all, b squared, then by b, then by the 56. So I am going to have 6 multiplications when I am done. All right, let's do the blue 2 first. That would be b squared times 3b minus 4. B squared times 3b is 3b cubed. B squared times minus 4 is minus 4b squared. Let's do the red one second. That's the b times 3b minus 4. I have b times 3b is 3b squared. B times minus 4 is minus 4b. And lastly, I have minus 56 times 3b minus 4. 56 times 3 is minus 168b. Minus 56 times minus 4 is going to be positive 224. All right, we're going to collect like terms. We've got 6 things there, of which we have b cubes, b squareds, b's, and numbers. So final answer should be collecting like terms and simplifying. I only have 1 pile of b cubes. I have 2 piles of b squareds, and I have b's, minus 172 of them. Numbers 224. Done. If you had chosen instead to multiply those 2 first, and then multiply everything by b minus 7, you should have the same answer that I did. Number 14 is our doozy. It is 5a minus 3 squared times 2a minus 7. Be careful. 5a minus 3 squared means 5a minus 3 times 5a minus 3 times 2a minus 7. I'm finding all this writing up above a little bit intimidating, so I'm just going to get rid of that. Okay, now we can see ours a little better. We have 3 things to multiply. It doesn't matter what order you multiply them in, but I'm going to do left to right again. I'm going to do 5a minus 3 times 5a minus 3, called a perfect square. I end up with 25a squared minus 15a minus 15a plus 9. Bracket, write the 2a minus 7 again. Tidying up that first bracket, because I have an extra term, I can combine that. Minus 15a and minus 15a is minus 30a plus 9. 2a minus 7. I've got a trinomial multiplied by a binomial. I make sure that I multiply the 25a squared with both things in the second bracket. 25a squared times 2a would be 50a cubed. Then I make sure that I multiply the minus 30a by both things in the second bracket. I will get minus 60a squared. Minus 30a times minus 7 is positive 210a. Then I make sure I multiply 9 by both things in the second bracket. I have positive 18a minus 63. I have, why do I feel like I'm missing one? I am. All right, I am missing the second term right here. 25a squared times minus 7 minus 175 a squared. All right, now we're going to collect like terms and simplify. I have a cubes, a squareds, a's, and numbers. A cubes, I've only got one pile. 50a cubed. A squared, I have minus 175 of them and minus 60 of them. Minus 235, a squared. My a's, I have 210 and 18. And minus 63. 1, 2, 3, 4 terms. I have given you loads of algebra practice below. Please make sure you do some of all or all of it. You need the practice.